that have on H2. We should see an increase in H2, right? So now we have our 3 arrows, so we can start looking at our data sets and trying to figure out, okay, which data represents SAM. So I'm just gonna start at TRH because it's the last one. So we know that you should have a hyperproduction or overproduction of TRH, right? So what 2 values in the TRH column represent an overproduction?
A and D.
A and D, right? Because 85 is greater than 40 and 55 is greater than 40. So that checks out, cool. Now we're gonna move on to our next hormone. So we should see an overproduction in H2 or TSH. And so which values are above 50?
A and C.
A and C, right? And now we're gonna look at T4. So we know that T4 is going to be hypostimulation or like less, right? Which values are less than 1?
A and D.
Yeah, A and D. Which data set satisfies all 3 criteria that we need in order to identify SAM?
A.
Data set A. So which data set represents SAM? Data set A. But now we're gonna practice identifying pathologies because I really want you to understand what this means. So when we're identifying pathologies, where should we always start? Always start, when you're identifying pathologies, always start at the first hormone. So H1. In this case, that's TRH because we're in the thyroid pathway. Start at H1. So we have an increase in H1, we should see a increase in H2. So that checks out. Draw a little check mark. Okay, that works. That follows our like idea and concept of tropic hormones. So now we're doing tropic hormone 2. H2, we have an increase in H2. We should see an increase in H3. Is that what we see?
No.
Nope. There's an error. Something's happening here. Do we know what? No. We don't have enough information to decide like what's going on here. We just know like, okay, there is an error in this section. But let's again practice just for the sake of it. If we have a decrease in H4 or H3, sorry, T4, H3, what relationship does H3 have to H1? An inverse relationship. So if we decrease H3, we should see an increase in H1 because of negative feedback inhibition, right? Does that check out in this situation?
Yes.
Yes, because if we decrease T4, we see an increase in TRH. So that works. So where does our error lie? In a primary pathology, right? Cool. So now we have Barbara, and I'm gonna let y'all try this on your own, and we'll go over it again just to make sure that we're all feeling good. But before we start with Barbara, I'm gonna go ahead and kind of walk you through her disorder because this one's a little complicated. So Barbara has Graves' disease, which is not good. So it's an autoimmune disease in which an antibody produced completely mimics TSH. And so if we are mimicking TSH, what should you expect? An increase in what? We're mimicking the behavior of TSH. So what is being influenced by TSH? T4. So if we're mimicking TSH, what we should see is an impact on T4. So what this means is that if we're mimicking TSH in the body, we should see an increase in T4. So I'm gonna let y'all, knowing that information, knowing that we should see an increase in T4, I'm gonna let y'all try and figure out the rest and then match the data set.
Would that also mean that like it's observed in a test? Like this antibody would then be observed if you were measuring TSH, or would it not be observed since it's like completely mimicking
So in this place, it doesn't say that TSH is eliminated. It just says it mimics it.
Oh no, I'm just saying like TSH that they showed here in a data set, would that be included in that data set, like the antibody that's came in, since it's supposed to be completely good? Like, would it be?
It would more so impact T4 because it's mimicking TSH, then it would just have the same behavior function, which would then secrete T4, stimulate T4 function, right? I'm not necessarily sure if it would show the test score, but it would evaluate it. I wouldn't necessarily take that as the way to identify it, because I think it's a lot more complex than that thought process. But just like the simplest way to determine it is just to draw that line and know that anything above this line is secondary pathology, because secondary pathology, it could be relating to something that's wrong with the hypothalamus, something's wrong with the pituitary, maybe something's wrong with the target tissue, we don't know. We don't have that information to make that deduction.
How'd you decide where to go?
I just draw it because ultimately, like, it's deciding like the hormones that are being influenced. And so secondary, I guess, yeah, it's impacting Trojan hormones. The primary is not, it's impacting primary, which is not.
Yeah.
So I think it's a lot more complex than how I would answer it to you. And you're not expected to understand why.
So I'm just saying, you were said like everything about that secondary below is primary, right?
Yeah.
And then, but how do you decide where to draw that line? So like on an exam of fluid, how do we know like, oh.
Just know that the first H1 and H2 should be above the line. So there should be two hormones.
So we'll